Hello, this video will cover section 1.5, simplifying radical expressions. Class 0305 with the co-requisite of Math 1324. The radical expressions that we will be working with are not just going to be square roots. We will also use other types of roots, and that will be determined by the index, which will be the little number that you will see outside the radical. Now, the radical is the symbol that I'm tracing, and the stuff that we have inside that symbol, inside the radical, is called the radicand. So, for example, that would be the 36 to the fourth power. In this case, the index is a 3, and I just want to remind you that if we had something like the square root of 81 squared, let's say, we know that the index, it is an implied 2 because we call that the square root, not the first root. However, we don't write the number, but we still know that it is a 2. We also have two types of roots. We have even and odd roots. So for example, since this is a 2 even number, that will be an even root. We also have like the fourth root, the sixth root, and so on. Now here for odd roots, we have the cube root, or the fifth root, or the seventh root, and so on. That becomes important because of the way that we answer the question, or based on the input or output will depend on that. For example, even roots, we need to have, for us to be able to get a real solution, we need to have a positive radicand, or greater than or equal to 0. And for odd root, it doesn't matter if we have a negative number or a positive number, and it would still be okay. Now, if we were to have a negative number, then we're going to be using this concept of the square root of -1 is equal to I. So I'm going to do a quick example. If we had something like the square root of -9 and you put that on your calculator, it will tell you no real solution or error or undefined, because to be able to answer a question like that, you will have to use imaginary numbers. Now, in the class 1324, we do not use imaginary numbers. However, there's still a requirement in Math 0305, so we're still going to cover briefly. So just to answer this question, the square root of -9, you will have to factor that -9 into -1 times +9. And then we will take the square root of one of the factors at a time. So 9 will be 3, and the square root of -1, based on that, it is I. And so that will be the answer with imaginary numbers. Also, I just want to point out that if we had, for example, the square root of 9, the answer to that, it could be +3 or -3, because 3 times 3 is equal to 9. But -3 times -3 is also equal to +9. However, in this section, we will only focus on the positive answer. In the next section, since we will 1.6, since we will be using the quadratic formula, we will be using both the positive and the negative square root. So let's get started with the first 4 statements. We need to fill in the blank. So the first one says, find the, oh, well, by the way, these are the steps for simplifying radicals, which is the purpose of our lesson, and that is the title as well. So first, we're going to find the prime factorization of the radicand. And remember, the radicand is what's inside the radical. Then we're going to determine the index. Remember the little number outside the radical. And we need to know that because that will tell us how many of a kind you need to put in a group. And so that we could take that either number or variable from inside the radical to outside the radical. So for example, if we have an index of 2, such as the one for the square root, then you need to get 2 of a kind to move that number or variable from inside to the outside. You will see that once we start doing the examples. So let's move on here to number 3. Then you move each group of numbers or variables from inside to the outside, like what we were saying on the previous step. If there are not enough numbers or variables to make a group, then those will remain inside the radical. Also, notice each group of numbers or variables gets written only once when they move outside the radical. So if we were to have, I don't know, let's say outside the radical x times x cubed, then we will have to multiply x times x cubed, and then we will just have x to the 4th power, so that x is only written once. Now, next statement says, separately, simplify the expressions both inside and outside the radical by multiplying. So, like the example I was talking about, x and x cubed, we will say x to the 4th power. So let's get started with our example 1a. And we have here our radicand. The number inside is 252. So that is the prime factorization that we will be doing. And the index for this problem is a 2 because it is a square root. So what I'm going to do is only use prime numbers. So in this case, 252 could be divided by 2, and that will give me 126. Then we can divide by 2, that will give me 63. 63 could be divided by 3, that will give us 21. Now, 21 could be divided by 3, that will give us 7, and 7 could be divided by 7, and that will give me 1. Now, from here, I can see that I could group 2 and 2, 3 and 3, and then 7 will just be by itself. So the prime factorization of 252 is going to be 2. Since we have 2 of them multiplying each other, it will be 2 to the 2nd power times 3 to the 2nd power times 7. So what I'm going to do now is I'm going to rewrite the problem, or the radicand. So instead of having the square root of 252, we'll have the square root of 2 to the 2nd power times 3 to the 2nd power, and then times 7. So that expression is the same. The square root of a product, it is the same as the product of square roots. And so let me write it here. So we will have the square root of 2 squared times the square root of 3 squared. Then we will have the square root of 7. Those two expressions are equal. And now what I'm going to do is simplify by taking the square root of a square. Those two are inverse operations, so we could say they cancel each other out. Now, the answer for that will be what comes out of the square root will be just the radicand without the exponent. And so that will be 2. Now for the next one, we have a square root. Remember the index is a 2, and that's why it also, makes sense. It gets canceled with that. Remember 3 squared is 9, so if you were taking the square root of 9, it would just be 3. So that 3 is going to get multiplied here. And now the square root of 7 is here with the exponent of a 1. That one will just remain inside because we didn't have another 7 to group them and have 7 squared. So then that one will remain inside the radical like that. So now the answer will be 2 times 3. So that will be equal to 6. And then the 7 stayed inside the radical, and it will look like that. 6 times the square root of 7. There's no sign in between them, so we know they're multiplying each other. Now let's do part B, and then we're going to go back to almost the same radicand, so I will go over the prime factorization again. But let's move on to a different number, 180. So remember, when we factor or divide, we're only going to use prime numbers. So in this case, we could divide, I know we could divide 18, we could divide it by 18, we could divide it by 10, we could divide it by 30, but I don't want to do that. I want to just break it down into prime numbers and see how many groups I can make from factors that are the same. So we could divide by 2, that will give me 90, then divide by 2 again, that will give me 45. So this is what I was talking about, making groups. Now I have 2 squared right there. 45 could be divided by 5, and that will give me 15. Now 15 could also be divided by 5, and that will give me 3. Now 3 is a prime number itself, so it can only be divided by 3 or 1. So if we divide by 3, we get 1. And now here we have another group, 5 and 5, so that will be 5 squared. If I write the prime factorization of 180, that will be 2 squared times 5 squared, and then times 3. We only have one of those, 3 to the first power. So now we're going to rewrite this expression. Instead of 180, we will use the factors that we have listed here. 2 squared times 3 squared times, I'm sorry, not 3 squared, but 5 squared. 5 squared times 3. And now remember that this expression is the same as the square roots multiplying each other. We could also write it in this way, the square root of 4 times the square root of 25 times the square root of 3. So now if I take the square root of 4, it will be 2. If I take, which is also the square root of 2 squared, the square root and the square cancel each other out, so that will be 2. Now the square root of 5 squared, we could cancel the square root with the square, and that will be 5, which is similar to, or the same as the square root of 25, will be 5. And then finally, the square root of 3, the square root of 3, that one remains inside the radical. And for our final answer, we're going to multiply the two numbers that came out of the radical. So 2 times 5, that will be 10. And then the number that stayed inside the radical, you just need to write it right next to the 10. So the square root of 3. 10 times the square root of 3. The homework that you do on my math lab sometimes requires for you to leave your answer as the exact answer. And so it is important to know how to simplify expressions like that one, because putting it on the calculator it might give you a decimal approximation, and sometimes that is not what my math lab is asking for. So now we're going to move on to part C, and part C is just like A. The difference is that we have a negative radicand. So we're going to do the factorization again. So 252, we divided by 2, we got 126. We divided by 2, and then we got 63. Then we divided by 3, and we got 21. Divided by 3, get 7, and then divide by 7, you get a 1. So for the prime factorization, we use prime factors, and we keep dividing until we get a 1. So we made the groups, and we had something. In this case, we have negative 252. So when I factor that, it will be negative 1 times 2 square times 3 square times 7. So when I rewrite the expression, it will be the square root of negative 1 times 2 square times 3 square and times 7. So we already know that we could break this down into the square root of negative 1 times the square root of 2 square times the square root of 3 square times the square root of 7. Remember, all of the roots are multiplying because inside the radical, the factors are also multiplying. So by definition, the square root of negative 1, we're going to use the letter lowercase I. And so once we get to that one, we could say the negative 1 will be taken out of the square root, but it will be represented with the letter I. Now, if we take the square root of 2 squared, it will be a 2. And the square root of 3 squared will be a 3. And then the square root of 7 will just remain like that. Now, we're going to multiply the 2 times 3, so that will equal to 6. Then we will write I. Just like if we were writing 6x, we will want to write the number first, so it looks like the coefficient. So this will be 6i. Remember, it's 6 because we multiply 2 times 3, and then the square root of 7 will remain inside the radical. So now we're going to do example D in the same way. So we already have the prime factorization of 180. So what I'm going to do is say this will be equal to the square root of negative 1 times 2 square times 5 square times 3. And so that is equivalent to the square root of negative 1 times the square root of 2 square times the square root of 5 square times the square root of 3. And here I'm going to go ahead and start with the number. So the square root of 2 square, that will be a 2. The square root of 5 square will be a 5. And then the square root of negative 1 by definition will be I. And then we leave the square root of 3 inside. Now I'm going to multiply 2 times 5, so that will be 10i times the square root of 3. And that will be the final answer after simplifying. Okay, so now we're going to move on to the next page. And here for our example, next example, example E, we have something with an index of 5. So because of that, when we do our point factorization, it will help us if we can make groups of 5. So we're going to start by dividing 243 by prime numbers only. So I could divide this by 3, and that will give me 81. Now, 81 I know is divisible by 9, but I want to use a prime factor, and so that would be 3. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And then we need to divide one more time. 3 divided by 3 equals 1. That's how we know that we stop. And if you count how many 3's we got, multiplying one to the other, we have 5 of those. So we could say that the prime factorization of 243 is equal to 3 to the 5th power, which is actually very convenient because the index of this root is 5. So now to rewrite the problem, this will be the 5th root of 3 to the 5th power. Now let's see what we're going to do with the variables. So for the variable to the 7th power, I want to separate. Here we know we have multiply by itself 7 times. And what I want to do is break them down or rewrite them so that it shows that I have a group of 5 of those and then 2. So in this case, x to the power 7 will be x to the power 5 because that's what's convenient for the type of root that I have. The index is a 5. So x to the power 5, but then I cannot forget about x times x, so that would be x squared. Now for the y, inside the radical we have y to the power 8, so we're going to factor it or break it down with y to the power 5 times y to the power 3rd. Now to go back and just check, we could use that property that tells us that if you multiply 2 of the same variables, you add the exponents, and y to the 5th power times y to the 3rd power is y to the 8th power, like we have there. Similarly, x to the 5th power times x squared will give us x to the 7th power. And so that's what we're going to use here. So instead of x to the 7th, we have x to the 5th times x squared. And instead of y to the 8th, we will have y to the 5th times y to the 3rd. Now we're going to separate the radicand into roots. So that will be the 5th root of 3 to the 5th power times the 5th root of x to the 5th power. And then we have the 5th root of x to the 2nd power, the 5th root of y to the 5th power, and then I need one, so that would be the 5th root. Sorry, I'm writing over the 243. I'm just going to erase it. So that was the fifth root of y to the third power. Now we can go ahead and cancel. So this was 3 to the fifth power. That gets canceled with the fifth root, so that will be 3. And let's see, we could write this down, see what we're going to leave inside. X, the fifth root of x to the fifth power, that would be x. And then this x squared will remain inside because we only had 2 of those, and we were not able to make another group of 5. Here we'll have the fifth root of y to the fifth. So that will come outside. And then the y to the third power will remain inside. Remember, those two expressions are multiplying. I'm not saying that the index is the exponent of y. That is telling us the fifth root. Okay, now let's move on to f. And for that one, I'm going to just clear my space here. I'm just going to leave the answer. For that one, we found 3 x y times the fifth root of x squared y cubed. Okay, now the next problem that we have, it is of a square root, so we're going to be trying to make groups of 2. So let's start by factoring 216. 216 could be divided by 2, and that will give us 108. Then we can divide by 2 again, and that will give us 54. We could divide by 2 again, that will give us 27. And that could be divided by 3, and it will give us 9. Divide by 3 again, it will give us 3, and then divide by 3 one more time, because we want to end up with the 1 on the left. Now, the numbers here are the prime factors of 216. And we see that the prime factorization of 216, it will be 2 to the power 3 times 3 to the power 3. However, I want to make groups of 2, not 3. So what I'm going to do instead will be to rewrite 216 as 2 square, but instead of writing it with 2 to the power 3, it will be 2 squared, but we still need to make up for that other 2 missing, 2 to the first, or just 2. And then that would be times 3 to the power 2 times 3 to the power 1. So I am splitting the 3 to the power 3 that way so that I can take the square root of at least one of the groups. Now I have x to the power 5, and what I need to do is think of how I could factor this so that one of the exponents will be divisible by 2. So I'm going to use x to the power 4 times x. Now for my y's, it will be, instead of y to the power 8, actually that works perfectly, because that could be, is an exponent that is divisible by 2. So I'm just going to leave it like that. So the idea is that if we are taking the square root of y to the power 8, that is the same as y to the power 8, And remember what we discussed about the index of the square root is a 2, is an implied 2. We don't write it, we don't see it, but we know it's there. So this will be y to the power 8 divided by 2. So that index becomes the denominator of an exponent. And because of that, the answer to that would be y to the power 4. And so that's what I'm going to do with this part. Now, what would happen with x to the power 4? Well, the square root of x to the power 4 will be x to the power 4 divided by 2. And so that will give us square. And so that's why I'm factoring my variables so that they have powers of that are divisible by 2. So now I'm going to rewrite this expression. So we have the square root of 2 square times the square root of 2 times the square root of 3 square times the square root of 3 times the square root of x to the 4th times the square root of x times the square root of y to the power 8. Okay, and just like we have been doing, the square root here and the square will cancel each other out, so this will be 2. Here I'm going to add that one in there, the square root of 2. The next one, the 3 will cancel. I'm sorry, the square root will cancel with the square. And we take the 3 outside the radical. This one will remain inside the radical. The next one, it will be like we did here, x squared. Remember, all these things are factors, therefore they're multiplying each other. The square root here, I'm going to circle the ones that we're keeping inside the radical. Square root of x, so we just leave it like that. And then for the last one, the square root of y to the power 8, it will be y to the power 4. Now I'm going to write the ones that were taken out of the radical first. So the square root of 2, remember multiplication is commutative, so we can change the order. Then we had an x squared, and then we had y to the 4th. And then inside the radical, we kept the 2, the 3, and the x right here. So I'm going to still have them inside the square root. 2 times 3 times x. Okay, now just to simplify our answer fully, we need to multiply the 2 and the 3, so that will be 6 x squared. Now I'm writing this 2 factors, y to the 4th. And then inside the square root, we still have 2 times 3, which is 6, and then x. And that will be the final answer. So we're almost done. We only have 4 more problems to go. However, G and H, they have the same radicand, except that one of them is negative, one of them is positive. So they're actually the opposite of each other. So I'm going to start with H because it has the positive radicand. So I'm going to start doing the prime factorization of the number 176. So that number can be divided by 2 because it ends in 6. That would be 88. We could divide that by 2 and we get 44. Divide by 2 again, we get 22. Divide by 2 again, we get 11. 11 is a prime number, so we could only divide by 11 and we will get a 1. So prime factorization of 176 will equal 2 to the power 4 times, because we have 4 of those, times 11. Now the fact that we have 2 to the power 4 is helpful because the index is a 4, meaning we're taking the 4th root of that radicand. So for the x to the 3rd power, That one, there is nothing we can do to break it apart because we only have 3 of those. And that tells me that x to the third power is going to remain inside the radicand when we write our final answer. Now for y to the sixth power, we could do something because we will have 6 of those multiplying each other. So if I group 4 of those together, then I will have 2 of those left. And so I will break y to the sixth power as y to the 4 times y squared. So now that I have the radicand completely factored, oops, I don't know what happened. Okay, so I lost my prime factorization, so I'm going to rewrite it. So we were talking about using 2 and it was not that problem that we were doing, it was actually this one. So instead of 176, we were going to use 2 to the fourth power times 11, and then we will use x to the third power times y to the fourth power times y to the second power. So what I was explaining was that the y to the sixth power was going to be split into 2, y to the fourth, y squared. Now that one, we could rewrite it as the fourth root of 2 to the fourth times the fourth root of 11 times the fourth root of x cubed times the fourth root of y to the fourth, and then times the fourth root of y squared. Then we simplify. This fourth root will be with the exponent 4, so the 2 comes outside the radical. Now the 11 is just raised to the power 1, so it's going to have to remain inside the radical. Now x to the third power will also stay inside. And now when we get to this one here, we could cancel the fourth root with the exponent of the y, so the y comes outside the radical. And then finally, this one here will have to remain inside. And remember, those two expressions are multiplying each other, so you wouldn't have to write them like that. You could just write one next to the other. Or if you're not sure, you could also put them in parentheses. Now, moving on to problem G, the prime factorization will be the same. However, we still need to account for this negative number. And so for that, it will be the fourth root of -1 times 2 to the fourth times 11 times x to the third power times y to the fourth, and then times y squared. So in this case, we already know what the answer will be. However, the fact that we have here the fourth root of -1, so I'm going to leave it like that as two factors multiplying. And then I'm going to use the same answer that I have here. Like that. Now, unfortunately, we cannot use the same expression that states that the square root of -1 is equal to I. To be honest, I do not know how to approach this problem here. And so I typed it in my calculator, the one that gives me imaginary numbers as solutions. And I typed it as this: -1 to the power of 1/4. And so what I obtained from it, and I don't remember exactly, but I think it was, I'm almost sure, so I'm going to say approximately 2/2 plus, no, it wasn't 2/2 because then it would have said 1. I'm not sure what it was, but it turned into a complex number. And so because of that, I would just feel more comfortable for this class to just leaving the answer in this way. It's just my opinion because we have not covered operations with imaginary numbers, so I don't really want to go over how they got that. And so it will be something like that. If this was a 2/2, then it could have been like a 1 plus I. I'm not sure. You could try to enter it on the calculator, or even better, you could ask your instructor just to make sure if that would be okay to leave the answer like that on the booklet. Now, I'm going to move on to the next two because I just want to finish this video. And we have here square root for both. We have a positive radicand, we have a negative radicand. So we're going to start by getting the prime factorization of 150. So 150, it could be divided by 2, and we will get 75. We could divide 75 by 5, we will get 25. 25 divided by 5 is 5, and then 5 could be divided by 5, we get a 1. So we will factor 150. The index for that problem is a 2, so it will be 2 times 5. We can make a group of 2, so 5 squared times, we still have this other 5. And then for x, x to the 6th power, we will just leave it like that. And then for y, we will break that into y squared times y, because we want to make those groups of 2. So right here, 2 and 5 will remain inside the radical. Also, y will remain inside the radical. Now, that is not 25, it's 2 times 5. For this one, y squared, that will come out as a 5. 5 squared will come out as a 5 because the index is a 2. So that will be the same as us saying 5 to the power 2/2. And that will be just 5 to the power 1, which is 5. X to the power 6, since we are taking the square root, it will be x to the power 6 divided by 2. Remember, the index becomes the denominator of that exponent, and that will give us x to the power 3. Because of that, x to the power 3 comes out radical. And then lastly, for this one, for y squared, it will be y to the power 2 divided by 2, which is y. And that's out of the radical. So just to finalize the answer, it would be equal to 5x to the 3rd power times y, and then radical 2 times 5. Remember, those two were multiplying, so that will be a 10 times y. So that will be the final answer. And we have just one more problem to go. So the prime factorization of 294, we could divide by 2, and that will give us 147. Then we could divide by 7, and that will give us 21. 21 could be divided by 7, will give us a 3, and then 3 could be divided by 3, and finally we get a 1. So to rewrite that radicand, we cannot forget about the negative, so we will have -1 times 2 times 7 squared, and then times 3, and then times x to the 4th, and for the variable y to the power 9, I'm going to split it using an exponent that could be divided by a 2. So I'm going to use y to the power 8 times y. So I'm going to write it as the product of square roots one last time. So that was the square root of -1 times the square root of 2 times the square root of 7 squared times the square root of 3 times the square root of x to the 4, and then times the square root of y to the 8th, and times the square root of y. So from there, and because of the definition, the square root of -1 is just I. We're going to leave that one inside the radical. 2. The next one will come outside of the radical, 7. The next number will stay inside the radical, the square root of 3. The next one will be x to the power 4 over 2, which gives me x squared. So we will take that outside the radical. And then for y to the power 8, this one, that would be similar to y to the power 8. Well, the square root of y to the power 8 is the same as y to the power 8 divided by 4, which is y to the power 2. So that will also come outside, and that will be here. And then finally, for this one, it will remain inside the radical. So the final answer to this problem is going to be 7x squared y squared times I times the square root of 6 times y. And that's it. This is the end of the video.